Good evening, everyone. Today we will discuss about the properties of Z transforms. First, we will discuss about linearity property. Linearity property states that if x1 of n is going to have the Z transform to be x1 of z with region of convergence R1, and if the Z transform of x2 of n is going to be x2 of z with region of convergence R2, then a into x1 of n plus b into x2 of n will have the Z transform to be a into x1 of z plus b into x2 of z. So we should note that here this x1 is nothing but the capital X1, which is going to be the Z transform, and here also you have capital X2, which is again the Z transform, whereas you have this side small x1 and small x2, which are nothing but the sequences. So in this case we will have the ROC to be R1 intersection R2, that is the common region between R1 and R2. Now let us prove this result. Proof: we know that z of x of n equal to x of z, which is summation n equal to minus into plus infinity x of n into z power minus n. That means here we are using the bilateral is a transform. Now what is that we are going to prove? We will just try to substitute x of n to be a into x1 of n plus b into x2 of n, which is going to be summation n runs from minus into plus infinity a into x1 of n plus b into x2 of n into z power minus n. Now what we could do, just multiply this z power minus n inside for each of the terms and take the summation for both these terms. You have summation n equal to minus infinity a into x1 of n into z power minus n plus summation n equal to minus infinity b into x2 of n into z power minus n. So I hope you understood this step. Now the next step is we are pulling out this a and b from summation. So a is taken out, taking summation inside, summation n equal to minus into plus infinity x1 of n into z power minus n plus pulling out b into summation n equal to minus into plus infinity x2 of n into z power minus n. Now this term we could write it as capital X1 of z, and with b term again you have capital X2 of z. So which is written as a into capital X1 of z plus b into capital X2 of z, and the region of convergence is R1 intersection R2. So this is the proof. So we have proved the z transform of a into x1 of n plus b into x2 of n is a into z transform of x1 of n, which is capital X1 of z, plus b into z transform of x2 of n, which is capital X2 of z. So we will go with the next property, the time shifting property. What does it state? The time shifting property of z transforms states that if x of n you have and you're going to take z transform for x of n, that will give you x of z with zero initial conditions and ROC is the real line, then x of n minus m, if you take the z transform of x of n minus m, that will give you z to the power minus m into capital X of z with the region of convergence R, except for the possible addition of deletion of the origin or infinity. So we are going to prove this result. Proof: we know that z of x of n is equal to capital X of z, which is bilateral transform n equal to minus into plus infinity x of n into z power minus n. But now we are just trying to plug in z of x of n minus m in place of x of n here. So what will happen here? It is x of n, so x of n you get, but here it is x of n minus m. So in the formula when you apply, this place will become x of n minus m into z power minus n with summation. And now we are trying to replace n minus m equal to p in the summation. Then what happens to n? N will be m plus p. So we're just making this change n minus m as p, and this n will become minus of m plus p. And here, when you closely watch this one, what will be p from this? P is n minus m. So when n tends to minus infinity, p will also tends to minus infinity, and when n tends to infinity, p will tends to infinity. So this thing you need to keep in your mind. The reason is you're gonna change this in terms of p. So let us change that. Is it of n x of n minus m is equal to, here I'm gonna change n as p. So as I told you, p is nothing but n minus m. So when you substitute n as minus infinity, p becomes minus infinity, and when you substitute n as plus infinity, p is plus infinity. X of n minus m is replaced as p, x of p. Z to the power minus n is replaced as m plus p inside the brackets. So now the next step, we will try to take this powers and split it, z power minus m into z power minus p. Pulling out z power minus m, that will be the next step. We will have the summation which is running, p is running from minus into plus infinity with x of p and z power minus p. And what is this? This is nothing but the z transform. So we will get minus x z power minus m into x of z. So this is the result which we need to prove. Z of x of minus m is z power minus m into x of z. So I hope you understood these steps. So this is the final answer. You can see this x of n minus m is nothing going to give the z transform, which will be z power minus m into x of z, or the z transform of x of n minus m will be z to the power minus m into x of z. So I hope you understood this property. And also, when you have this change here, instead of n minus m, if you have n plus m, the z transform of x of n plus m will be z to the positive m x of z. So that will be the formula for x of n plus m. If the initial conditions are not neglected, we have time delay z of x of n minus m equal to z to the power minus m into x of z plus z to the power minus m into summation k equal to 1 to infinity x of minus k into z to the power k. And time advance property z of x of n plus m is equal to some z to the power m into x of z minus z to the power m summation k equal to 0 to infinity x of k into z to the power minus k. Now this difference equations concepts will be dealt with using time shifting property, and we can arrive at the formula for difference equations here. So the time shifting property is very useful in finding the output y of n of a system described in the difference equation for an input x of n. So we have the formulas here. Z of x of n plus 1 equal to z into x of z minus z into x of 0. So how we arrive at this result? You just replace m as 1 here. So here z power 1 is z into x of z minus z to the power 1, which is z, into expand the summation x of 0 into z power 0, which is 1 into x of 0, which is x of 0. And the remaining terms, when you have a k value which is running after 0, 1, 2, 3, etc., for those values we will not consider, because we are neglecting those values. We are not neglecting the initial conditions, so we will have this rule. And now z of x of n plus 2 will be z square into x of z minus z square into x of 0 minus x of 1. And z of x of n plus 3 will be z cube into x of z minus z cube into x of 0 minus z square into x of 1 minus z into x of 2. So these formulas are very important in solving some problems in inverse z transforms. So the next property is multiplying by an exponential sequence property. The multiplication by an exponential sequence property of z transform states that if the z transform of x of n is capital X of z with ROC is real line, or then a to the power n into x of n, when you take this transform of this a to the power n into x of n, that will give you x of z over e with ROC modulus of a into real line r, where a is a complex number. We will go with the proof. We know that z of x of n is capital X of z, but now we just want to use this x of z, which is summation equal to minus into plus infinity x of n into z power minus n, which is the bilateral formula. Now in place of x of n, we need to replace a to the power n into x of n. If you do so, what will be the answer? We will just see this. So how do we get this? Let me tell it here. Summation n equal to minus n to plus infinity. Instead of x of n, we have a to the power n x of n into z to the power minus n. So now this will lead to x of n is here. So let us have a z inverse power n. Now we need the z transform rule. So we can write this as a by z, but still I am writing it as z by a whole power minus n. Why? Because when you pull a down, it will be like z inverse by a inverse power n. So that will give you z by a whole inverse power n, and that will give you z by a power minus n. So that is how we got this result. Now you closely watch this. In place of z power minus n, you have z by e. Therefore we could say that this is equal to z transform of z by e. So that is how we derive this result. So the z transform of a to the power n into x of n, which is the exponential sequence multiplication, which leads to capital X of z over e. And we can very well note, if this a to the power n is replaced by e to the power j omega n, then the z transform of this term will be x of z by e to the power j omega, which could be written as x of e to the power minus j omega into z. In similar way, we could write e to the power minus j omega n into x of n as, the z transform of this term as x of z by e to the power negative j omega, which is x of e to the power j omega into z. So these are some formulas. When you replace a to the power n as e to the power j omega n, then you will get these results, which will be useful somewhere in the problems. Now, the time reversal property. The time reversal property of z transform states that if the z transform of x of n is x of z with ROC real line, then x of minus n, if you take the z transform of x of minus n, the negative n, then you have x of capital X of 1 by z with ROC 1 by r, right? Let us go with the proof. We know that z of x of n is equal to x of z, which is equal to summation n equal to minus into plus into x of n into z to the power minus n. But we need z of x of minus n, so we just replace x of n as x of minus n here, and remaining places are going to be same. Now we will replace again p equal to minus n in the above summation. So what will happen in that case? Here you could see I'm going to replace p as minus n. So when you have minus infinity, so what will be your p? P will be negative infinity, which is positive infinity. And then when you when you have n value to be plus infinity, your p value will be negative infinity. So again we'll end up with p to be negative infinity to positive infinity, and x of minus n is taken as p, x of p, z power minus n is z power p. So this is the way of working out this result, and then we will prove that it's equal to x of 1 by z. Now the next step, z of x of minus n is summation p equal to minus n plus n t x of p. Here we will have z inverse whole power minus p. So this one, how it comes, you have to be clear. Actually it is z power p, but here it is, you just want to make in this way so that you will end up with the result. So because of this step, what you will have in place of z, you have z inverse. So that's what we have here. So this is nothing but the capital X of z inverse. In place of z, you have z inverse. But what is z inverse? It is 1 over z. So x of 1 over z is the result. So the z transform of x of negative n is equal to capital X of z inverse, or x of 1 by z.